Okay, we're going to now do a video, a lesson on similar figures, all right? So you're going to be introduced to this, and we'll work some really fun problems in class about this. First of all, for shapes to be similar, three things have to happen. And this, by the way, is what we use to show similarity between two things, okay? Instead of writing down the word all the time, we use those two little wavy lines. Okay, three things are, they have to have the same shape. A rectangle can't be similar to a triangle, because two different shapes. The corresponding angles must be equal, and the corresponding sides must be in proportion. So we're going to explain and flesh that out a little bit. For example, here we have two triangles. They're both right triangles. So we're going to see if they could be, we're going to see what it looks like if they were corresponding. All right, they are the same shape. They're both right triangles. If the angles are corresponding, I'm going to show you how to tell if they're corresponding. Well, definitely, since B is a right angle, then E is a right angle, so we can say that B and E are corresponding. Okay, B corresponds to E. Okay, now A is up from B, angle B, I should say, is corresponding to angle E. Angle A is right up on the shorter side of that triangle. So the shorter side on this triangle would be angle J. So angle A, you could say, corresponds to angle J. And I'm just using the arrow instead of writing down corresponds every time. So that would leave angle C here would have to be corresponding to angle G. Okay, so that's how you see how the angles correspond. If A, whatever the measure of A was, if A was, say, 60 degrees, and they were corresponding, then angle J would have to be 60 degrees, because they have to be equal. We already know that B is 90, right, because that's what the box means. That means a right angle, which is 90 degrees. And by the way, we do know in a triangle, all the interior angles are 180. So this is 60, this is 90, this would have to be 30 degrees. I knew you knew that. So if these two angles are corresponding, then that would mean that this would be 30 and this would be 30. And they'd be equal. That's what the corresponding means. Now, if the sides are corresponding, now we've got to see which sides are corresponding to which sides. Well, which side would correspond with the short side here? Well, if that's AB, we could say that short side AB has to correspond with EJ. Okay? And this long side, BC, would have to correspond to the long side, EG. Now, it doesn't matter whether you sometimes you put lines on there to show the sides. And that's all what you learn about in geometry. We're not going to focus on that right now. But you could say EG, or you could name this side GE. It does not matter. Some people may be more picky about that, because B was where the right angle is, so you should say E first. And that'd be a good practice to get into. So it would be very good to learn to do that. Now the last side, the longest side, we call that the hypotenuse, which you'll learn about later in the year. This AC would have to correspond to the side JC. But let's see, A is 60 degrees, and I put that first, so I think I'll put the J there first, because it's a 60-degree angle, and that'd be GC. So that's how you can tell, how you begin to show what does corresponding mean. Corresponding means it'd be in the same position. Okay? All right, let's look at some other examples. Okay, so number one, are these similar? Okay, well, let's check the three things. First thing, are they the same shape? They're both right triangles. Okay, look like they probably could be similar. Are the corresponding angles equal? Okay, that's my symbol for angles, by the way. Okay, are the corresponding angles? Let's see the corresponding. Well, this right angle corresponds with that right angle, so that has to be, they're equal. They're both 90 degrees. This one's 40, and this small angle is also 40, so they're the corresponding ones, and they're equal, and then similarly for the 50. All right, then you have to check to see if the sides are in proportion, and here's how we do that. We have to make sure, remember now, in proportion means that the ratios are equal. The ratios of the sides are going to be the same, they're going to equal the same one ratio. All right, so let's just do the small side to the small side. Just the small side to the medium side, I'm sorry. So this small side is 3.6 of this first triangle, and that's 4.8. So put that small on top, the medium on the bottom. Then we see about the small side here is 24, and that has to be to 32, because that's the medium side of that triangle. So it's sort of like you have it almost like the Punnett squares you're learning about, that the small side and medium side, and then this is the first triangle, we'll call this the first triangle, and this is the second triangle, or you could say the smaller one, the larger one, but you might get mixed up with that, so I don't know. I'm going to say that's the first one in the picture, this is the second one in the picture. Okay, so if you can take the cross products, remember, you could either do cross products or you could reduce them. Okay, we'll take the cross products, or no, actually we reduced it, I guess. Yes, and so when I divided by 1.2, when I divided these by 1.2, I got this is 3 to 4, because 1.2 goes in there 3 times and 4 times. And then same thing when I divided by 8, this still reduced to 3/4. So these equaled each other. So that meant that, yes, these sides are in proportion, okay? You could also do another way. You could write the proportion. You could do small triangle on top. So the small side is here, and then the medium side, and then the large triangle, the small side of the large triangle is there, and then the medium side of the large triangle is there. And then when you reduce those, again, you get 3/20, which they're both equal. 320 equals 3/20. So that's all in proportion. And we do know for a triangle now, if these sides, this side's going to be only one length that this side can be, and it's got to be corresponding to that because of other things that we haven't learned about yet. But instead of going through a whole nother set, you can see that those are. Okay? All right, next examples. We want to see if these two rectangles are similar. All right, so they're the same shape, both rectangles. So far, the corresponding angles are equal. Why can I say that? Well, what do you know about all the angles of any rectangle? They're all 90 degrees, so you could just put all boxes in there. Okay, so they're all the corresponding ones are going to be equal because everybody's 90 degrees. Now, you want to see if the sides are in proportion. Well, here we only have two sides to check because that's the only different measures that we have. So we take the small side over the large side. So small to large, 8/21, is that going to equal 5/17? We can't really reduce them, so we're going to take the cross product, and we see that no, the cross product is not equal, so they do not. These are not similar. Now we have this here. Suppose two shapes are similar. Remember, there's a similar sign. Suppose you're given that they're similar. Can you find the side lengths? Kind of working the other way around. Okay, so you set up, if they are similar, then their sides are going to be in proportion. So the large side to the small side is going to be the same as the large side to the small side. Okay? Remember now, anytime there's pictures, they're not necessarily drawn to scale. So make sure that you're thinking that, even on the test that you're going to get at the end of the year, they always say, that they're not drawn to scale. So I didn't draw these to scale. So you have large is 13 to 6, okay, to small. Then what would you put? Don't put 5, because 5 is the smaller side. Even though it's like, I switched, I switched it. I forget what that word is. Anyway, so the 5 is not the largest, the small. So I put that in the bottom. The Y is the larger side. Okay, it's larger than this. So that much you do know by the picture. Okay, so I do take the cross products. 13 times 5 equals 6y. Divide by 6. I get that y is 10 and 5/6. Okay. All right. Next couple examples. All right. We can use similar figures to find lengths that are pretty difficult to measure. We've actually, sailors use this when they're out on sea to see how distant the shore is and all that kind of stuff. There's a lot of very geometrical applications to this in real life. But we're just going to do a little tree and a person, okay? We're going to say the tree is 18 feet, his shadow is 12 feet. The person has a shadow of 2.5 feet, so we don't know how tall that guy is. All right, so we do height to shadow. You can put shadow on top and height on the bottom. You could do the person let's just do this right now. So we have 18 to 12, and we have n to 2.5, because we don't know his height. Take the cross products, and we get that they're 3.5 feet tall. We could have reduced this and then done the cross products. That might have made it a little bit easier. That'd be good. Okay, so now another situation you're going to have a lot of is on a map, for maps, because maps are definitely things we can't, measure right easily, I guess I should say. So on a map, 1 inch is 100 miles. Okay, if two towns are 4.5 inches apart, what's their actual distance? Again, we put inches over miles. Again, you can just go 1 over 100, then 4.5, because that's the one you do know. You do know the inches, so the n would be on the bottom. You do the cross products, and you get 450 miles. Okay. Now, a couple of definitions before we keep on going. We have scale drawing. A scale drawing is simply, it's in a large picture or a reduced size picture. That's all it is to the actual length. But it's similar because it increased proportionally or decreased proportionally. And the angles stayed the same. Same measure. Now the scale, you talk about a scale is the amount that it's enlarged or reduced. Like if you enlarge your picture 3 times, 3 would be the scale. If you shrunk it a half would be the scale. Okay, for example, in our last problem about the map, the scale was 100 times. I put that in quotation marks because it really wasn't 100. It was 1 inch to 100 miles. It wasn't like 1 mile to 100 miles. So but you can think of it as being 100 times in a sense. And that would be our scale for that particular example. So maps themselves are scale drawings, and so are blueprints. They're going to give a lot of examples of things that is very applicable to. Okay, so let's try another one about the map. If you have 1 foot is 15 miles, a very big map. If two towns are 135 miles apart, how far are they apart on the map? Okay, again, you got 3 numbers. You got proportion. You can just make sure you put feet on top, miles on the bottom, or if you want to do the other way around, that is fine. Take the cross products and divide, and those towns on the map would have to be 9 feet apart. That's a really big map. but that's the answer. Okay, last one. Okay, if a class is 50 minutes long, okay, and we are 2/3 of the way through, how much time is left? Now, this is a very tricky problem, so you have to really be thinking when you're doing this. Well, you can do a proportion of minutes to the class, okay, so 50 minutes is one class. Now, I started to put n over 2/3 because you have 2/3 there, put it there, that's what we've been doing all the time, but you have to be careful because it's asking how much time is left. So you've already used up 2/3. So if 2/3 is used up, how much is left? 1/3. Okay, so 1/3 is left. So you do the cross products, you do 50 times 1/3, so you divide 3 into 50 and you get about 16 and 2/3 minutes. When I did it, my mistake, I did 2/3, I got something like 33 minutes. And I thought, wait a minute, that can't be right. See, I checked my answer because it can't be 33. If 2/3 is already gone, that's like about, that's a little bit over half. So that's how much, I actually got how much we already were in class 4. I didn't get what they had left, okay? Hope that makes sense. All right, so let's take it the other way. Let's say how much of a class has been taught if 20 minutes have gone by. Same class, 50 minutes. So you do the same proportion, 50 over 1, same ratio, and then 20 over n because you don't know how much of the class. And do your cross products, and it turns out 2/5 of the class has gone by.